All right, gang, thanks for checking in. Let's talk about electricity a little bit today. So just real fast, I want to show you up here. So on that pole across the street, and I'm not sure if you can see it too well, but there's a gray transformer. It's a transformer up there, and it looks a cylinder looking thing. And high voltage gets fed into that, and then that voltage gets dropped down, which we can go into that later, and then it comes down these lines here, comes over onto our pole, comes across here. I'll bring it over here and just show you real fast. Comes on over and gets into what we call a weatherhead. So the weatherhead is that steel pole that comes up and it's got that head up there on it. The power company, they tap into that, and then after they tap their wires into it, of course, then they bring it down. We bring it down into the meter. Comes into the meter, then goes into the panel. Typical, just like at your house, same thing. Power comes in, may come in underground, could come underground, but this one here we come overhead. So anyway, that's the power coming in. Now we'll go look at a panel real quick and I'll show you a little bit about that electricity. So hold on just a second. All right, so we saw out there where the power comes into the house, you saw the wires coming from out there on the pole where the transformer was at, and that gray cylinder thing, that's a transformer. It just drops the voltage down so that we can use it safely in our home. So let's look to see where it comes into the panel. So this panel is completely dead. There's no power on it. I've already verified it. Nothing on here, no power, can't get hurt. I've already checked all that out. But so as you can see, the power company has brought in 3 wires. You've got your what's called neutral wire, your line 1, and your line 2. So with line 1 you've got 120 volts, line 2 you got 120 volts. If you combine them across both of these bars, that's 240 volts, which is what your air conditioner at your house is probably being run off of. So this 120 volts is setting right here in your panel and feeding all your breakers just like you'd have at your house. What this voltage wants to do is it wants to get back to this neutral wire so that it can go back to the power company and go what I call going home. So in order for this to get home, it's got this 120 volts of pressure, comes up, goes through your safety breaker, comes out your black wire, comes down just like at your house. You've got a receptacle. Of course, I don't have a plate on this one to keep the kids from sticking their fingers in there, anybody sticking their fingers in there. But anyway, so the power comes down, and then I pull this receptacle off just like you'd see at your house. Same thing. You got that black wire over here. That's 120 volts. That's that pressure that the power company is delivering. That pressure comes down, goes into a radio, a TV, a hair dryer, a battery charger, maybe an air compressor, or whatever, and as that voltage comes down, it feeds these devices, and then that's what makes them turn on and run and play and charge batteries and do that. And so once the power, of course, comes down into the radio, for example, it's got to come back up, because remember, it wants to take a path back home, so it's got to come back out of the radio, the TV, the lights, anything. It's got to come back and come back up, and as you're going to see right here, we've got the white wire set here, and we're plugged into the receptacle, and this is the other side of it. It's got to take a path. Electricity's got to take a path, come back out, come out the white wire, we come back out the white wire, and then come back into the panel. We've got a bar back here which is called the neutral bus bar, and that's where we hook all our whites and neutrals that come down and tie into this, which this is the neutral wire, which now is going to go back to the power company. Because remember, when voltage comes in, goes through the breaker, it wants to go out and do work and turn lights on and air compressors and battery chargers and radios and hair dryers and blah blah blah. It comes back in. It's got to get back onto this. If it doesn't, nothing's going to work. Okay, so now that we've mentioned that, let's talk about what electricity actually does and what these devices do, you know, like your hair dryer or your radio or your lights or whatever. So once this voltage right here 120 volts, we'll just use this side for example. Once it comes in, and it comes up and feeds your breakers, as you can see, these breakers have numbers on them. You know, it's got the number 20 right there. Hope you can see that. Anyway, so that's 20 amps of current that it's going to allow to flow through this before it trips. Let's say it's on and it gets more than 20 amps and it trips. So you're asking, what are amps? So as your 120 volts comes in here, it's the pressure again. The power company's pushing 120 volts in this wire. In all wires, there are millions, if not billions, of what's called electrons. These electrons are being pushed from the power company with this voltage up through your breaker, and these electrons flow through the breaker. Electrons come out, keep being pushed. They're still being pushed down into the radio and to the battery and to the air compressor, hair dryer, whatever. What's interesting about this is that once those electrons are being pushed, let's get back over here, they're being pushed up through your breaker, and your breaker's got 20 amps of current on it, and the voltage is pushing those electrons through into your lights or to your hair dryer and such. Each device has what's called a resistance in it. So your hair dryer's got a resistance to the flow of electrons. Lights have a resistance to the flow of electrons. Excuse me. Hair dryer, TV, it all is pushing back. So there's a resistance in there that keeps those electrons from flowing through there too fast, or also as they flow through, they've got to get back over again through the hair dryer, through the lights. Those electrons got to get through that device and then get back over to the white wire. So what I call it is when voltage is pushing those electrons through those lights, hair dryer or whatever, and each one of those devices are pushing back, they've got a resistance. What that's actually doing is what I call gobbling up that voltage. So that 120 volts getting gobbled up or being used or work in the lights or the hair dryer or whatever. It's got to do work. Once it does work and uses up that voltage, then it returns back, that current returns back through your neutral bar and back to the power company, which is what it's got to do. So that kind of gives you an overview of what electricity does. And I know that there's probably some questions about it, and I'll be glad to answer any questions. But that's kind of just a real quick gist of what electricity does and what it is and how it works. So pretty neat invention, actually. That probably one of the best inventions in the world. That was devised, and so really neat. I'm really excited about talking about electricity and pretty neat, all the different facets. But it kind of sparks an interest in you maybe to study electricity or look at all the variable things that electricity does to things, to motors, how motors work, how dryers work, how TVs, just different things. So really interesting. But anyway, just wanted to show you that real quick. Appreciate you watching, and also go check out my YouTube channel, sorry, Red Rover, and please subscribe. Hey, thanks for watching. Talk to you later. See you on the next one.